Yeah, welcome to the session again. Circular linked list, right? So, and we have also discussed about how we can come back so that there is no only forward direction, how we can get back to the previous nodes. So we got two things to be done. Like one is double linked list and the other one is circular linked list. So based on the hint and the program which I have helped you last time, you might have understood how to construct a circular linked list, right? Only one difference between a normal single linked list and a circular single linked list is every time you create a new node, instead of none, you say it is as root. So by the time it is already connected to the root, its next address is not none, but it is connected to the root. Earlier, every time we connected a new node, it is always none. That's what we created because the last node is always none. The new node will be included into the linked list, and of course, it becomes the last node. And the last node will always have none. But here, for a circular linked list, your not none you will be converted to root. So instead of leaving no address there, you connect the address to the root node. So this is how you perform a circular linked list. But a small thing is that whenever we are creating a root node here, we cannot write root here itself. So you might ask me, sir, why can't we self address ourselves? But before creation of the root, you cannot address that. In C programming, it is possible because you first create a root and then you build the value and the address there. But here itself, we are building the value and address. So if it is not possible, without constructor, we need to do other thing. You can also self address yourself. But here it is not possible based on our construction. So what I have done here, only the first root node starts with none. That's what I have done. And after that, I pass the root's address to root duplicate. I will keep this as my standard reference so that it will always stay with the root and the traverser traverse from one node to the other node. So anyway, for the first time, if there is only one node in the single linked list, that is itself the root node. So naturally it is starting with none. Why do you go to while loop? There is no need for you to traverse all those things. So simply what you do is you do traverse dot next add is equal to new node. That's all. And you see every time the new node starts with a connection to that root address. Of course, this is root duplicate, but holding the same address as root. And after that, if it is not the only node, so if the linked list is containing more than one nodes, naturally you will never find none. The none is only found if there is only one node in the single linked list. But after that it will connect to the next one, and finally the last one will connect to the root. So you will never find none in the nodes, right? So naturally you will skip this and your while loop will work now. So you will traverse until you find out a connection to the root. So determining that this is the last node. So you skip the while loop and simply you write your traverser dot next node is equal to the new node. Okay. So this is where you will find out. So if you have reached the last node whose next node is connected to root, you cut that root and connect to the new node because the new node is already connected to the root. So circular linked list will always be there. So we can go forward to even include 100. The 100 is also included there. You can see the 100 is connected to the root node already, but it's not connected to the linked list. Now the traverser travels from 5 and it comes to 20. You can follow this line which I have marked red, you see. Okay. So, and then it comes to 16 and then it comes, so 16 end because it's the root node, because 16 has a root connection. Now you remove the root connection, connect it to 100 because 100 is already connected to root, so that it always forms a circular linked list. Yeah, you can see here. If you want, you can check out 5, 20, 16, 100 and again 5. Okay, this is what a circular linked list that we have formed. Just a second. Okay. So this is the circular linked list that we have formed now. So along with this, we have also discussed that there is another way to get back. It's also most beautiful way of construction of a linked list. This is not called single linked list, but it is called double linked list. A double linked list has two directions. You can either move forward or backward. So here, why we constructed a circular linked list? Single linked list always goes to one direction. It will start at this position and slowly go from one position to other position. So what we have done, if we come to this last one, we cannot go back. So we again constructed a circular one so that we again come like this. This is the way we can go. Anyway, it is all forward direction. Then without circular, how can we come back like this? So then you need to have a double linked list. Let us move through double linked list. Let us say how the double linked list will be. My expectation is I will first draw a raw diagram of only elements. So it will be 6, something like 20, 5, 16, 100. Maybe these are there. So this is actually the root. So 6 should connect to 20, 20 to connect to 5, 5 to 16, 16 to 100. And in the same way, 100 to 16, 16 to 5, 5 to 20, and 20 to 6. This is the way you connect a double linked list. So earlier, this is DLL, double linked list, right? We write the same thing in the single linked list so that you will understand. The same 6 is connected to 20, is connected to 5, is connected to 16, is connected to 100. So this is single linked list. Now if it is a circular linked list, the same thing happens. It is always forward direction, but the only difference is that you will have a reconnection to the root every time. The only principle you need to understand is that whenever you add a new node, reconnect to the root and then add it to the list. So 100. So this is again connected to this one. So these are the difference now. So you already learned about what is a single linked list and what is a circular linked list. Circular, of course, you need to say circular single linked list because its shape is completely like a circular single linked list. Whenever you add a new node, you are always forming a circle. So in that way, you actually add your circular linked list. So in these two, you can understand the disadvantage is you always move forward. For example, you came to 625. Why can't you go immediately again backside if you need to really read all the back previous nodes? To read also in a circular linked list, you have to go through these things until last and come back like this. So, but in double linked list, you see you can go to 25 and again from 5 to 20 and 6. So there are some scenarios where you have to move forward and also sometimes to move backward. So anyway, when we do our programs on linked list, we will definitely understand why the double linked list is needed, what is the advantage of that, and what is the advantage of single linked list. So if you understand these two, double linked list is very easy. Now let me draw the structure of a double linked list. The structure of a double linked list is when you are trying to connect two nodes in forward and backward direction. So this is what we are expecting, right? If this is so, then definitely one should be connecting to this and the other should be connecting from the other one. You see, you can understand that. For a forward connection, you always had the next address, right? The next address. But for before connection, what you should have? Definitely the before address, the before node. Again for this arrow, it should be next address. Again for this arrow, it should be before address. So that means for all the nodes, one before address and next address. Before address, next address. Before address and next address will be there. So that is why it is called a double linked list. So let us see how it will be connected to. 1 second. So how it is connected to? Let us see. Now I will draw a original diagram of doing this, including the addresses. Like the same thing. The value in the middle, 6. And anyway, the first root node will always have null, right? So the root node will always have null. The before, there are no before nodes. So root node is connected to this and it is connected to none. I will write none as n. Let me have an address for this 2161. 2161. And I will draw the other node which I need to add. So you need to understand that you have to create a concept that is a node which is a double linked list node. Okay, so that means it is this time you need to create a new class called a node with 2 addresses and value. Earlier we only have 1 value and 1 address. Here 2 addresses with 1 value. Now I will write this one as 6125 as an address, and the other one is 5126 as an address, for example, like this. Now can you tell me what I need to fill here in 6?
6125.
Yeah, 6125. Okay, that's good. So we are connecting to this one, right? What should I fill here? The before address of this node?
2161, sir.
Yeah, 261. What should I fill here?
5126.
Yeah, 5126. What should I fill here?
6125.
6125.
And this is none because that's the last node. So because we are connecting, so 2161 is connecting to this, 5126 is connecting to this, 6125 is connecting to this, and finally that's finished. So you have your values in between, like something like 100, 20, and so on. So this is a double linked list. So first of all, let us construct a concept of a node in the double linked list. How do you construct a concept? We can say this is as previous address, this is as next address, and this is as value. Okay, now we will do a small class node with double linked list. I will open a live session because this is the new one. Okay, live programming mode. I prefer this because every time you can just see directly. Okay, class node. So our node in double linked list concept is this one. Definition init self. So what are the things I need to receive here?
Value
Before address, value after it.
Okay, we will say the previous address PA, value, and next address NA. Okay, so we will receive like that. And so I will write self dot pre-address PREADD is equal to PA. Self dot value is equal to V. Self dot next address is equal to NA. Simple addition is just we are going to pre-address. That's all. Our concept is done now. So as usual, we prefer like this, right? If name is equal to, sorry, it's a comparison. So you can say main. So I'm writing everything in the main function. Main, and then we go back to define the main now. Definition main, right? So first of all, I need to create a root node. Now tell me, how can I create a root node? Root is equal to, tell me, I will type.
None.
Yeah, node of, yeah, tell me.
First none, sir.
None. Okay, because the root node would have definitely none. Next,
The
anything,
value.
some value 6. Next, do you have the next address for the first node every time?
No, sir.
No, sir.
So every time it should start with none. Finished. So you have done a node with that. So you can see it in the memory if we go like this. So you have a root and you say that it is the node instance and it is referred by a root in this. What are the things that it is having? Next address is none, previous address is none, and the value is 6. Okay, now we created our first root node. Now I want to insert some values here. So insert the same thing, the same function that we want to insert. So insert some value like 100 this time. And first I need to send root address, right? Because we want to traverse it like our previous single linked list. So root, next what I need to do, 100 is a value that is being sent. Right. Now, based on the single linked list, you dictate me what to type in the insert. So I will say insert traverse. So I will say traverse, only TRA. Okay, TRA for traverser. So it is receiving the address from the root. So I am receiving a value here, V. Now tell me what should I do now? What is the next step? You have to include a new node into a linked list, right? The new node is containing a value 100. How do you create a new node? Tell me.
Traverse.new address.
No. First create a new node like the root. First create a new node.
Equals to node.
Yes.
A new node equal to
Yes. New node equal to
node of
node of none, because every node has to start with none and the value that we received and also none. Like your root node, it has to be done. Next. After this, now you need to traverse, I think, whether it is single node or full nodes, you need to see which node is having the next address as none, the same way. Then you stop there and add the new node. Tell me the logic now, like single linked list. I write file. Yeah, tell me.
So first we want to check the whether the linked list is empty or not.
It's okay. See, once we have created the root, there is no need for every time. See, what is an empty linked list? We have not created anything. But anyway, we are sending root, right? Root address is sent. So already root is there. So there is no need for you to check. You can directly go for adding new nodes.
Okay.
So tell me the logic, anybody? While
Traverser dot next add is not equal to none.
yes, traverser dot next add not equal to none, right? That means we are looking in the forward direction. Let's go back to the board. See what we are doing. I will now say that, okay, first you have created the root node. The root node we have kept it as, so both are none, right? And what is that we have kept the value? It's 6, right? In the root node. So we are having 6 here and we are having some address. Let me write it in some color. So 2161. So this is the root node that it is pointing to. You want 100 to be placed next. So 100 is your target. So you have created another new node. Okay. And next address as NN, and in between you have kept 100. So now what you have done, you have started your traverser here. The traverser starts with root and checks if the traverser next node, that means the next address is none or not every time. Yes, it is none by this time. So what you need to do, you need to skip the while loop. So I'm writing that one. Until then, you can say traverser is equal to traverser dot next address. If a traverser, that means wherever node the current traverser is pointing to and its next address is none, I'm not talking about previous address. If its next address is none, you skip the while loop, come out and say traverser dot next address is equal to new node. So this is what we have discussed right earlier in the single linked list also. Now let us see whether it is inserting or not. Let me insert some other things like insert. I even told you the advantage of why we are using functions like insert. Why can't we directly write everything in main? So because we have repeated statements and also our root is being completely moved away, we are losing the first elements. We are losing the link for the first node. So that is why we always keep the root there in the first node, create a duplicate called traverser and move the traverser from the root to the last node. But still root is holding the first node. Remember that. So this time 101, insert, something we are, some fishy thing we have done that you need to correct me after seeing the output 120. Okay, now let's run it. So based on the diagrams, you need to tell me what to do for the modification in the insert. Let me
So we are not storing pre-address.
Yeah. Let me first check this output, then we will do it. So root 100, right? Right. So new node is being created. So new root is having 6 value and we are creating new node. Okay. So now you can see in the insert function that traverser is there with 6 and new node is there with 100. Now we need to connect these two. See how I am connecting. I'm checking while the traverser, now the traverser is pointing to this, right? So traverser's next address is none. So I'm skipping while loop because the while loop condition is you need to go inside the while loop only if the traverser's next address is not equal to none. But because it is none, I'll skip that and go to the 17th line of my code. So what I have done here, traverser dot next next address is equal to new node. Okay. So I have connected, fine. So your traverser next address is equal to new node. Okay, this is where you have connected, right? So this is your list. Root is pointing to this one and this one is pointing to this. Everything is fine now. Let us connect in the same way. Let us come to next 101 creation. Yeah. Now tell me what is missing here.
Pre-address.
If you are connecting only next address, what is the difference between double linked list and single linked list? So in this diagram, you are purely missing the connection with the pre-addresses. So your pre-address should not be none in the second node. Your pre-address should be holding this node, right? And this pre-address should be holding this node, and your next address should be none. So now tell me the modification of what to do in the insert. I'm only saying TRA next address is equal to new node. Now tell me what to do. How do you connect the pre-address to that one?
So new node dot pre-address equal to TRS.
Okay, new node dot pre-address is equal to traverser. Now, see how it is connecting. Have you seen this? TRA's next address is connected to, let me do one step. Yeah, TRA's next address is connected to 100. And 100's pre-address is connected to the TRA, whether it is root or something. I think you understand, right? The next address is connected to the next node, and the previous address is connected to the previous node. And because the root is only the first node, its pre-address will always be none. So in double linked list, the last node's next address is none, and the first nodes, that means the root node's pre-address is none. So we are satisfying this one. So see, simply adding this statement really helps you. Now, again, we will go back, create a new node 101, and our traverser starts here. You follow the red pointer. So it says while TRA's next address not equal to none. Yes, it is not equal to none. So definitely we will go into the while loop and move the TRA to the next node. And see, the TRA is moved to the next node. And next, again while TRA dot next address is not equal to none. Now what you will do now? Again you need to see that it is equal to none. So it is not satisfying the condition. So come out of the while loop, come to the 17th line. Now you see the TRA. What is the present TRA? This one, which is holding the value 100. So the what is in the 17th line that we have written? TRA's next address is equal to new node. So this none, which I am now underlining in the memory, will be connected to this node, right? Let us see. Yeah, now it is connected, right? And this previous address of the new node will be connected back to the node with value 100, you see. So I think you understand now. So after finishing it, this is your final double linked list. You see again, root is having the first node as 6. Its next address is connected to the next node. The next node's previous address is connected to the root, and the next address is connected to the next node. So the node with value 101, previous address is connected to the node with value 100, and the node with value 100's next address is connected to this. And you see, because 101 is the last node, you will have none here. As I said clearly, the previous address of the first node and the next address of the last node will always remain none. I hope you understand. Now, our next task is to display it. Display it. So, I want to display in both the ways. How do you do that? If I want to display, I want to display like 600, 101, and again 101, 106. Can anybody tell me the logic? So I want to demonstrate to you that I can come back also.
Sir,
Yeah, tell me.
sir, first మనం ట్రావెల్స్ డాట్ నెక్స్ట్ అడ్రస్ అలా వెళ్ళాలి సార్. అండ్ నెక్స్ట్ డాట్ నెక్స్ట్ అడ్రస్ నన్ను అయితే అండ్ నెక్స్ట్ న్యూ నోట్ డాట్ ప్రీవియస్ అడ్రస్ రావాలి సార్.
Yes, that's correct. So, can anybody, other people, can you define me how to do the display? So display. So as somebody has said, how you can go from one node to the other node, a small idea has been given, right? When you see none, again, you come back with the previous nodes. First, you keep on going with the next address. And after you see the final node, you keep on again going with the previous address. That's the right idea. So traverser, only traverser is enough because we are not displaying, we are not putting any new value. Now tell me, based on your previous single linked list thing, can anybody tell me how do you do that? You one hint is you can do two while loops. Two while loops. One is completely with next address and the other one is completely with previous address. Single linked list how did you do in single linked list? You tell me that to display.
Sir, can I?
Yes.
So while TRA dot next address not equal to none, print of
Yes.
TRA dot day dot
next
a value,
address
sir.
not equal to none. This is what is the same as single linked list. So you will every
Print.
time if you find the next address as none, you have to print it. So TRA
dot value.
So wherever the current TRA is, its value will be printed, and then move your TRA to the next address. Same as single linked list. And finally, we can, because we are at the last node and we skip away from this because it's the next address is none, and we need to print the final TRA value, right? As I have shown you in the single linked list. Otherwise, the last value will not be printed. Now, because you are at the last node already, again you start a while loop, TRA dot previous address.
Not equal to none.
Is not equal to
Not
none.
equal to none.
Yeah, you are coming from the last node again to the root node now. Again, you are coming back. Every time you print TRA dot
TRA dot value.
value, yes. What is this you have to write? TRA is equal to?
TRA equal to TRA dot pre-address.
Yes, pre-address. That's correct. So after that, you finally come to the root, right? There you will stop, and so you have to print the value. Let us see what will happen now. Okay.
At first one, you didn't remove parentheses.
Where is that?
Well, you didn't
Minus
give
this.
any display functions.
Okay, okay. Yeah. Display of root. So we are sending the address. Okay, right. So I think.
And then next at while dot traversal dot next.
This one you are talking?
Line number 24, sir.
Line number 24.
Yes, sir.
Yeah. Okay, thank you. So let me check out. So it is still connecting 120, I think. Okay. Let me insert 120 also. Yeah, this is our final double linked list. Now our turn is to now display the whole thing. So now it is coming. So you can see the traverser traverse through one by one, and you can see on top on the screen, which I have highlighted with green, you can see that each value is being printed. 600, next it will be 101, the final one will be 20. Now from here onwards, the while loop goes back. So pre-address, right? So pre-address, again 120. So 101, you can see there, see the traverser is going back. 106. That's all. We finished it. We have read everything, and this is how you display and insert something into it. So any doubts in this? It is almost all same as single linked list, but the only thing is that we add is something different. That is, we add one more address space to store the previous node's address. So whenever you go forward, you can also go backward. So that's how you can do it. Now, my next task is to delete it. How to delete it? So I will come back with my own idea of drawing these things, and I have to delete it. So 6. So this is the original representation, right? 100. connecting to the previous. And the next one is 11. And the next one is something like 120. So this is none, right? So I want to delete 11 here. So you, okay, first you delete the last element. Instead of this one, delete the last element. How do you delete the last element? I want to completely cut off the links, both the links. How do you do that?
Sir, we want to traverse each and node, sir, and we want to check the condition dot next address none.
So my question is, where to stop the TRA to delete the last node? Is it the TRA coming here or here? As I said to you, the story of cutting down the branch where you are sitting and where you are sitting next. What is that? Whether TRA is in the last but one node or the last node?
Last
Where
but
the
one,
TRA
the
value
third
is
one.
11.
TRA value should be at 11, and then you cut down the node with 120. So let me write the program now. So I will say delete. If I say delete root, so deletion in the linker list should always be deleting the link, not the node. So node will be existent in the memory, but it will be becoming orphan. So it is not part of your linker list. That's what the deletion of the node means. So delete of traverser. Okay. Now to delete the last element, what is the condition? Now tell me. Because I need to traverse, I will use while loop. Now tell me the condition.
TRA dot next. Two next, sir.
Okay. TRA dot
Next
next
dot next
address
address dot
dot next address. So it's not next address. Yes, okay. Next address, that's fine. Because we are deleting last element. Not equal to none. Same as your single linked list, whatever we have discussed. Okay, until then you go on. You stop at 11 and check its next address, because I have decoded everything, right, in the previous examples. So we have seen what are the things that you consider in the previous example, right? So here we have told what are the statements and how they are used for. So TRA's next address. Now the current address. What is TRA's address? Its next address, what it is, and its next address. So like that we have decoded in our previous class. I hope you remember. So this is how. So the current TRA in this case is 6125 and its next address is 1012 and its next address is 2021. So this is how you are linking up, right? So this is the decode that we will use the same thing in our program for the double linked list also. Now tell me, until none, what should I do now? What is the thing, what is the statement I need to write in the while loop?
Traverse equal to traverse dot next address.
Yes, traverse is equal to traverser dot next add. So it keeps on going until it comes to the node where it is the last but one node to delete it. So after that, what should I do now? I need two statements now. Earlier we used to just say our TRA dot next address is equal to none. That's all. Now we have to do two things. What is those things? What are those things I need to do? The two things are nothing but like this. I will tell you. So when you are at this one, I need to make this as none and this one also none. Now the question comes, which statement should be first and which statement should be second? And which one you will make none before and which one you will make after? Can you tell me? If I write like this, for example, I will write like this, a statement. Now you should analyze it. So TRA dot next address. Okay, if it is not none, we are coming, right? So TRA dot next address is equal to none. Now we will see in the diagram what will happen and we will do it. Okay. So the traverser is at 101, right? Now let's see what will happen. So okay, we have actually cut down 120 as a node. Previously 120 is there and we have cut down 120 as a node. But in my logical view, still 120 is holding 101. How is it holding? Let me check out. So I will write the same diagram. I will zoom a little bit so that you will understand. So we are at 11, right? We are at 11. Its previous address is connected to something, I think. Now I will write this address as 2125, for example. And in our case, it is actually 101, I think, right? So 101, this is 120. This example only we will take 120. The last address is none anyway. And the previous address should be 2125 because it is connecting to this. And let me write this address as 6152. And this is connected to this, and this is 6152. Some x, some address will be there here. Now what we have done, using this statement, now the TRA is here. We stop it because TRA's next address is none. So we stop TRA here. So we are not going through the while loop. So what I have done, TRA's next address is equal to none. So with this statement, what will happen, you are losing your next address immediately. See, you are keeping none. So what will happen? This link will be erased. But still you see here, your link is still holding. I don't want this link also. This link should also be cancelled. But how do you cancel it? Because you made it none and you lost its address. You know this, what is this address is. You don't know what is this address because you lost it. I want to cut this one. Any idea from your side? Did you understand the problem?
Yes, sir.
Now
Sir,
tell me. Yeah, tell
sir,
me.
after leaving the while loop, we have to put like traverser dot next address dot previous address is equal to none.
Yes, that's correct. So traverser's next address dot previous address. Now let us decode it. So whatever you friend said, so next address dot previous address, right? Our current TRA is at 2125. So dot next address dot previous address. What is 2125's next address? Initially it is 6152. Okay, before none it is 6152. This one. So what you will do now? It is equal to none. So what you will do? The TRA's next address dot previous address is equal to none. This statement should be the first statement. So it will be none. So here it will be none. This will be the first statement. So by this time we are rubbing off the link. And what is the next statement? As other person has said, it should be TRA's now the next address is equal to none. So now whatever the TRA's next address is will be made none. That's fine. So by this time you have rubbed everything. So we have completely deleted without any link hanging over with our linked list. We have completely deleted all the links with 120. Either the previous link or the next link we have deleted. So this is the second statement that you need to write. This is the second statement. Now let's fill out that thing. So instead of before this one, I need to write traverser next address dot previous address is equal to none. Okay. And the next one I have said is traverser's next address is equal to none. That's finished. But in memory, both looks the same. Okay, in memory both looks the same, and let us see how it works. See, in the memory 120 is connected to 100, 101, right? And 101 is connected to 120. Let's see what will happen with the 39th line statement according to our visualization. Now you see the previous address is cancelled now. So 120's previous address to 101 is cancelled and it is kept none. So completely we are breaking down all the links. And the next thing what we will do, we will cut down the 120 itself. So this is a simple way to delete it. Okay, so this is how you delete the last node. Why I'm saying you need to cut down all these links, because the next puzzle is how do you cut down based on your value. So we have a double linked list like this: 6, 11, 100, 120. So this is what your double linked list connecting to this one. Okay, if I want to delete 100, how do you delete it? The same way you have to come to TRA, right? Find out whether the next address is 100, like what we have discussed in the single linked list deletion of values. And then you need to try out connecting to this one. That means its previous address should be connected to this one and its next address should be connected to this one. See, now I want your logic. So will you try it? Because the time is already up. So this time deleting a new value, it will be quite challenging, because not only next address, you have to even check out the previous address. Of course, if you understand how you are getting the previous address and how you are getting the next address with these statements, you can simply understand how you can do that. Because I have given a hint that you will stop at 11 and find out whether its next address is 100. If its next address is 100, now manipulate using the statements. So TRA's next address should be your next address, right? And TRA's next address, previous address should be the TRA itself. A small statement change can actually bring you the entire logic. Without confusion, think about
Can I-
what. Yeah, tell me.
Sir, TRA next address equal TRA next address equal to
Hmm.
sir, just give me a minute, sir. TRA next address equal to TRA next address dot next address, sir.
Yes, that's correct. What is the next statement?
Next TRS, sir, sir, TRA next address dot
Anybody else?
next address dot previous equal to something.
Okay, not only you, anybody else. So he has told one statement. Can anybody tell me the next statement? How to connect this one? This is the previous address of 120, right? Initially, the previous address of 120 is connecting to the node with 100. So the simple thing is, he is even telling that. Can anybody tell me fast? So I will give you a small hint so that you can use this statement. So TRA's next address, previous address is equal to TRA. That's all. Because the present TRA is this one, right? TRA's next address and previous address will be equal to TRA. Simple thing. That's all. By this time, you will cut off the link. But again, which one is first and which one is second? This is very important here. Which statement you will write first and which statement you will write second. So somebody said the first statement is TRA's next address is equal to TRA's next address, right? But by this time you are losing the address of this. How do you get 120's previous address connected to you? So remember which statement works first, which statements work second. So decide yourself and come back to the next class. Bye bye for today.
It's 1 o'clock.
Thank you, sir.
Okay, bye bye.
రెండు రోజులు ఎక్కుతారు కావచ్చు.